Okay, well, not bad. I mean, it's 8.5 hours. Okay. So we got a lot of ideas all over the place. The only thing we didn't put was transitive property. My guess is we didn't know what the transitive property was, so we didn't put it. Pretty much. Okay. Anybody know what the transitive property is? No? If A is equal to B and B is equal to C, then we also know A equals what? C. That's the transitive property. That's it. So if it can move, right? So it can take the place of that. We could also just call that substitution. But what I'm looking at is x minus 3 times 2x plus 1. And so I have a lot who say the addition property of equality. Can someone who told us that give us an explanation of why they said addition property of equality? Well, I got 6 of y'all who said it. So we got Tamia, Jaquan, Kadeja, Xavier, Mackenzie, and Jesus. I need one of y'all to give me a reason other than Mr. Kenyon wanted to be lazy and just put an answer. Is that what happened, Xavier? You didn't even think about it?
I didn't read it, I just said,
You what?
I was talking to Kiki.
If we just magically put addition property of equality and we don't actually think that's it, then we need to pick up a calculator and change it. Otherwise, one of you 5, tell me why you think it's addition property of equality. Jaquan, Jesus. Any ideas? There's a lot of us who did not say addition property of equality. Can someone come up here and show me, give me an example of what the addition property of equality might be? No ideas? Anybody have an idea or a situation where we might use the addition property of equality? So maybe with additive inverses? So what are you referring to when you say that? Okay, but when are we trying to create zeros? Come on. I need more information. Okay, to get a variable by itself, but what are you talking about? What are we trying to do? Y'all are not giving me mathematical language with that. Say that one more time, Mackenzie. In an equation, right? Okay. So, Caleb, show me what you're talking about when you say the additive inverse and all that stuff. No, show me. By the way, get your textbook out. You'll want it in just a second. Thanks, sir. So let's look at this. I need eyes up here. Which part of this is the addition property of equality? Say again. Not the adding 4. The adding 4 to create a 0 is not the property of equality. Say again.
Adding 4 to the 0.
Adding 4 to both sides of that equation. We need to be clear about this. We need to pay attention to this detail because this is messing a lot of us up. The properties of equality are purely to create what type of equations? Equivalent equations. What you all have always said for your entire mathematical career since you've been learning these concepts is whatever you do to one side of the equation, you do to the other side of the equation. That is called a property of equality. Whatever you do to one side of the equation, you do to the other, because that's creating equivalence, right? Now it's addition because we're adding, property of equality because we added 4 to both sides to keep it equivalent. Remember, these are called additive inverses, creating 0, which is called the additive identity, right? So that's all the language that goes into that. So 3x equals 4. What would be the next thing that I do to solve this equation? So you can divide by 3 or multiply by, remember that's called the multiplicative inverse, okay? Creating the multiplicative identity. And then it's called a multiplication property of equality, because what I did to one side I had to do to the other to make it equivalent. Now, having gone through all of that, look at all these answers again. What do you think, what can we use to multiply x minus 3 times 2x plus 1? I should see things changing for some of us. Okay. So let me ask you all something else again. What do I mean by a property of equality? What you do to one side of what? Of the equation, you do to the other side of the equation. So, can someone who put distributive property tell me why they put distributive property instead of multiplication property of equality? Keyshawn.
Because I see the equation, because multiplicative property, that means whatever you multiply, whatever you get to one side, you can do to the other. So since there's no equation, our only answer was distribute, and you can distribute 2x to x negative 3, 1.
Okay. So, no, you're good. Okay, so Keyshawn is saying, I don't see an equation to use a property of equality, so the only thing left is distributive. Someone who put multiplication property of equality, do you want to push back on that, or do you want to rethink that? Oh my, y'all, we gotta learn how to think. Come on, I need engagement, I need participation. If you're gonna keep multiplication property of equality, you need to justify your answer. Push back on what Keyshawn said. Or change your answer. Cool. Now I get to find out who I'm going to call on. Alright. So, Kadeja, why'd you put that multiplication property of equality? Push back on what Keyshawn said. Oh man, you weren't even listening when he was talking with you.
My nails hurt, man. I'm trying to...
Oh, my nails hurt, Mr. Kinney. My nails are preventing me from getting an education.
Yes, because I was trying to get into
Keyshawn, can you repeat what you said earlier?
Yeah. The reason why I thought it was distribute because with multiplication, multiplicative property of equality, you have to work with equations. And the expression doesn't give us an equation, so what are we multiplying to get that multiplicative inverse or etc. So our only option is distribute property because you can distribute that 2x, x, that negative 3 and plus something. You gotta find something that's equivalent to that. That's what it is.
So, to summarize, a big point that he's saying is, I don't have an equation, so I can't use a property of equality. Do you agree with him now?
Mm-hmm.
Do you want to change your answer?
I already did.
You already did?
Yeah, that's fine.
Okay, so we got 3 more holdouts.
Hold on, I can't change my answer. I want to.
Oh, you can't change your answer?
Uh-uh.
Hey Zeus, you want to defend your answer? Oh, you already changed it? Okay. Got one person on addition property of equality. Jaquan, you still want to change your answer at all? Come on, I need you to engage. So what are y'all used to? Because I would say this, I don't think most students are used to distributive property with binomials like this. What are you used to seeing distributive property with? So something like 3 times x minus 4? What about x times x squared minus 4?
Yeah.
Right? 3 times x would just give me 3x. Or 3 times negative 4 would give me minus 12. X times x squared would give me x cubed. Now I want to point this out because this is a detail a lot of students miss. Am I just randomly drawing arrows and then doing something? When I draw an arrow, I'm showing that I'm multiplying and I do the multiplication. Now I show the next arrow, what's x times negative 4? Okay. We go with that idea. So we might get a couple of different options, and that's completely fine. What I want y'all to do now is I'm going to stop this poll. I'm going to give y'all 3 minutes. You should probably write this down, pull out your textbook, go to activity 4.3. Should be like 180 something, roughly. Late 176. Okay. So we should be looking at 176. You got space to write there. And so you have a new poll question of use the distributive property to rewrite x minus 3 times 2x plus 1 as an equivalent expression. I am completely okay with incorrect answers. I am not okay with no answer. We should all engage, talk, and discuss. If you want to jump one group to the next, since there's no one in your group, go ahead and do that. No, I'm just going to have her jump back. One group. Guys, you will need to write this out. You cannot do this in your head. Very few people have developed their skills enough to do this in their head. Write it out. Nope. You just use the distributive property to rewrite. Right? So it's on the calculator. So I'm saying write out your work and then go from there and put it in the calculator. Come on, Jaquan, I need you to do something. If you're completely stuck, talk with your group. Let's figure this out. That's weird. It's like you have a small group to talk with. It's also weird because I see Sheridan doing something productive. Maybe you can talk with her, see what she's doing. What? Just x minus 3 times 2x plus 1. Use the distributive property. You're making that one harder than it has to be.
That's 8. I thought we was on 8 first. By numbers in the other parentheses. These 8 by those 2 numbers. That's what I want to know. And making negative 8 plus 1.
You know what makes it worse, Jaquan, is when you just sit there miserable and don't engage. If you start talking to people, it makes it social, it makes it more enjoyable.
Let me get some old problems.
Mine said 3 minus 1. It said 3 plus 1.
They left you with 1x from this word, x times x times 1. Then we have 3x, 3 negative 2x, which gives us negative 6. So it's plus
Yeah. Minus 3.
Hey Zeus, did you forget to put up your round up? Alright, let's see what, I'm not collecting it yet, but let's see what answers we have. I need some more answers. It takes time for some of these to update. Wait, what are you doing? don't do that, just type it in.
I'm not
Be careful, you put minus or negative 6x there, you have minus. Right? Yes, sir. Say again. Good at home. See where it says quick policy? So, we're going to get some more practice with it, but we should, I have 2, 4, 6, I should have, I don't know, 13 or 14 in there. Let's get our answers in, we'll get started in just a second. And I would pay attention as we go over this and write some notes down. I'm going to show you a new way to do this. All right. So we only got one answer that showed up multiple times. 2x squared minus 5x minus 3. Would one of the two who got that answer care to show us how you got there? Keyshawn, was that you? One of them? Who else got there? Xavier did as well? Did you give him the answer?
No.
All right, y'all got there together? All right. Come show us what you did. Pay attention to see if there's anything that you want to push back on, ask a question about, if you might want to change your answer as a result. Yeah, you can use that marker. So x, and you drew an arrow to 2x, and you got 2x squared. So x then times that 1, so plus 1x. So negative 3 times 2x. Okay. Okay.
Since I was left off here, I just added this part. I got 2x.
Good. There you go. Okay. Does anybody want to push back on that or ask a question about Keyshawn's strategy there? If you're not willing to push back, that means you should be changing your answer right now. Otherwise, we should be pushing back. Yes, ma'am.
I just got a question, how you get 2x squared?
Okay. Keyshawn, how'd you get 2x squared?
Because since I put x, since x times 2x, you're gonna add that x, because there's no, because, how to explain?
Well, don't forget, an easier way to understand it is, what is x times x?
X squared.
Oh, so we'll do, no. We
Okay.
added 3x.
Say again. You got a 3x? Yeah. Is that because it's a 1x times a 2x? Where'd you get 3x from?
You just added the x to the 2 to make it 3x.
So this times this? Yes? But remember, what is 1 times 2? We got to remember, with the distributive property, what are we doing? Multiplying, right? So 1 times 2 is 2x times x. That's x squared. Okay? Any other things that we want to push back on? Because I still only have those two answers. But if we're not pushing back on that, then that's what we're saying is we think they're correct.
You can do it a different way. Do this for
What do you mean?
You have
Can you have two x's in one equation? So one thing to clarify is, there's still only one x. Do you mean, can you have x in two different places?
Yeah, like I got negative 6x squared minus 3x.
negative 6x squared minus 3x. So where'd you get that negative 6x squared from?
So I distributed x to the 2x.
Okay,
And the 1.
okay.
Then I got,
So you got this? Yeah, okay.
I did negative 3. I distributed negative 3 to the equation down there. Then 2x squared plus 1.
Ah, I see what you did there. So one thing really quickly, remember that's an expression, not an equation, there's no equal sign. Okay? 2, and this is one thing I would recommend, or I would point out, when using the distributive property, you're distributing this x. Actually, let me show it this way. What's really happening is, maybe a way that might help us out a little bit, is you're taking x and you're multiplying it by 2x plus 1. You're then taking that minus 3 and multiplying it by 2x plus 1. You're taking this x and you're distributing it to this entire expression. Okay? You're taking this minus 3 and you're multiplying it by this entire expression. So the negative 3 is not being multiplied by this 2x squared plus x. Okay? Typically this is not how I draw it out, but you can. Notice you would then distribute inside of here. Like that. Okay? Traditionally what I do is, I just show it this way, with this x and then the arrows to show I'm distributing to both of those. Now one thing I like to do is, I underline here and I show it from the bottom so I don't get my arrows confused. Right, Liam? You awake over there? Come on, wake up. If you need to, stand up by the bag, write in your book, but we gotta be awake. Jaquan, if you choose to be miserable, you're gonna stay miserable. Come on, engage, learn something. You can learn this well. Alright. Man, it's this weird thing, Jaquan, when you were engaging and talking and being productive, you were learning really well, and then right after spring break, you quit.
That one I understood. I don't know.
It's weird, Jaquan, you didn't understand it at first, and then when you participated, then you learned it better. You're looking at it backwards. You're looking at it as, I'm struggling so I give up. No, you struggle so you engage, and then you enjoy it because you've engaged and you've learned it. You give it up on yourself. You give up on yourself, it's going to be miserable. But you're capable of learning this. Quit giving up on yourself. It goes for all of us. You got to make sure that you're putting in your best effort to learn. Questions, concerns, comments? Yes, ma'am.
What's a commutative property?
So the commutative property says this. X plus 5, that is equivalent to 5 plus x. They commute, they change places. Okay? 17 minus 5, that's equivalent to negative 5 plus 17. They'd be the same exact thing. See how they're changing places, those terms? That's it. That's the commutative property. You can also have a multiplicative commutative property. 2 times 3, that's equivalent to 3 times 2. Right? So that's when they switch places and they're still equivalent. Give the same value. Does that make sense?
So it's the same thing as an equivalent expression or equation?
So the transitive property, the distributive property can create equivalent, or transitive, commutative, and distributive properties can create equivalent expressions. But they're different properties that allow us to create equivalent expressions. Yeah. Yo, we are dead. I need everybody to stand up right now. Everybody stand up. Everybody stand up. Come on. Y'all got 5 jumping jacks and go. You heard me? 5 jumping jacks. Let's go. Wake up. Nah, stand up. Everybody's got 5. I'm watching. Let's go. 5 jumping jacks.
This camera?
Nah, 5 jumping jacks. Let's go. Congratulations, you got 5 jumping jacks. Thank you, Kadeja. Let's go. Come on, 5. Let's do it.
I did.
Come on, Liam. You need this. You need to get awake. Come on, Jaquan. You're not even moving your feet. I didn't ask. Do 5 jumping jacks. Get that blood flowing. Come on, I need those feet moving. Jaquan, you didn't move those feet whatsoever. Let's go. Huh? Okay. we start falling asleep again, you're gonna do 5 more jumping jacks. So, stay awake, let's go, alright? We got stuff to learn. And next time, if we gotta get back up, Liam, you're going to do jumping jacks.
I'll do
And
push-ups,
Jaquan,
I
you're
won't do
going to
jumping jacks.
move your feet as well.
I'd rather do push-ups than do jumping jacks.
Alright, then you can do 5 push-ups next.
Fine with me.
Alright. So, questions, concern, comments. I will say this finally, Keyshawn did this correctly. Okay? You have to take that x and distribute it. Now, one thing I would do is I would write all in line instead of vertically like this, because x times 2x is 2x squared, x times 1 is 1x, negative 3 times 2x is minus 6x, negative 3 times 1 is minus 3. Notice once we distribute, we're adding and subtracting those terms, and you combine the like terms. Okay? Huh? Yeah. Okay? So we're adding and subtracting those terms. Questions, concerns, comments?
Come on.
Alright. So,
Put 2x. That's what we would have.
we're going to look at our objectives quickly. Yeah, we have an understanding check. We got a test on Monday. I told y'all that we were supposed to have an understanding check today, and I moved it to tomorrow. At this point, we'll see. I have it ready to go. But again, I got to see what your understanding is so that I can adjust instruction tomorrow and Thursday, because we're doing Literacy for All on Friday, test on Monday. Yes, sir.
No, well, they keep my understanding check. Oh, I can't like.
That's- Okay, 1, Jaquan, I need you to engage more and you'll learn more. 2, I need you to do your reflections more and your homework more outside of class, where you are actually doing them 100%, looking at what you got, and study some. You're very intelligent, you give up on yourself. Quit doing that. Alright, so remember what we've been looking at is the characteristics and behaviors of quadratic and cubic functions, and notice how they're connecting to their factors. We've been building cubic functions from linear and quadratic functions. What have we done with our linear and quadratics to create a cubic? Say again? Multiplying. Remember, haven't we been dilating linear by, excuse me, another linear, or a quadratic by linear to create that cubic? So we're multiplying. We need to determine the zeros of functions and the multiplicity of the function zeros. And then we're going to connect that idea to the Fundamental Theorem of Algebra pretty heavily today. So, Ms. Courtney, y'all did wrap this up in here.
Yes.
Okay.
Yeah,
Y'all finished all of activity 4.2, does that sound right? Yes, right?
Yeah.
Yeah. So, I just want to touch on a couple of quick things before we move on. What we are looking at here with activity 4.2 was this function to start. What form is this cubic in? Those are all factors, right? It's in factored form. Is factored form the only way to write this function? Nope. Any guesses about what we might call the other form? We have standard form as well. We do not have a vertex form because we don't have a vertex with a cubic, but we do, I will say vertex form, remember, is very close to a transformed form, and so we do have that for cubics, but we're going to look at this in standard form today. Because it's a cubic, what degree was it? Degree 3, which means it had to have how many zeros? 3. Right? Did it have 3 zeros? Yeah. Remember, if we looked at this factor, we got what 0? X equals 0. If we looked at this factor, we ended up getting x equals, anybody remember? It should be on the graph on 4.2. There was an x equals 6, but would 6 be this 0? Be what? Remember, 18 minus 2x is equal to 0. Like, look at your graph. We should see. There you go, right? X equals 9. And then here, this was x equals 6. Remember, they're the x-intercepts, y'all. Or they connect to those. What multiplicity did each of those have? only had a 1. Remember, these factors only show up how many times each? Once. And so those zeros only have a multiplicity of 1. If you looked at the next function that we had pi x squared.
Teacher, students, sorry for the interruption. Any senior that arrived on campus second block or has not received their cap and gowns, please report to the theater. Thank you.
So what 0 did we have for this function? X equals? Huh? What 0 did we have? Huh? I can't hear you. Johnny, what'd you say?
Oh, I was talking to
Okay.
Okay.
Anybody know how we can find this 0? There's a couple ways. Okay, so remember we could set x equal to 0, we could set x cubed equal to 0. So what's the 0? Y'all, it's already done. I don't even have to do any work. What is the 0? 0. It's there. Look at your graph. Under activity 4.2, what was the x-intercept you had? 0, 0. Okay. Not for this one. It was for this one, or the second one. But that was the only 0 for the second problem, right? What multiplicity did it have? Multiplicity of 3, right? It was x being cubed. Which makes sense because how many zeros does a cubic function need? 3. What tells us that a cubic function needs 3 zeros? The degree, but there's a theorem that we've talked about that connects the degree to the number of zeros. Not zero product. Starts with an F. It's what the last question of this lesson was all about. And the fact that we don't know this last question is something we need to pay attention to. Fundamental Theorem of Algebra. Remember, the Fundamental Theorem of Algebra tells us, hey, whatever the degree is, that's how many zeros it needs, at least once we count the multiplicity. We go with that detail. Okay. Now, the last thing I want to point out before we continue to today's lesson is this. Do not forget, I can really see those zeros right away on the graph. Where do I see the zeros on the graph with my 3 linear factors? Okay? How did you identify those 3 points though? Because of what? So they're called what? X-intercepts, right? We want to notice those x-intercepts there. And so remember, that's how we can identify those different sections of the graph. You don't have to show these dashed lines, but you can if you want, just to sketch it or give yourself an idea. You need to be more accurate than what I'm about to do, but don't forget, this tells you a lot of important information right away. To the left of this 0, should my function